Okay, so next over to yet another one of our clinicians, Chris Lewis from the Park Medical Practice. So Chris is going to be talking about a primary care load management tool that he's been working on. Over to you, Chris.
Hi, I have a. Can you hear me?
Yeah, I can hear you
Yeah,
fine.
I have it all as a movie that I'm just going to play.
Okay.
So, what can you see now?
I can see that you're about to play a movie.
Okay, so I'll play a movie.
We can't hear anything, Chris. I'm not sure if it's supposed to be sound.
Okay, sorry, I'm used to Teams. I've not done this before. How do I?
You need to. So if you stop sharing and then reshare your screen, make sure you tick the share sound. There should be a share sound box that you can tick.
Thank you.
Don't worry, we've done it ourselves, including today.
Thank you. 1 second.
You may also, if you're sharing a video, you'll need to also select optimize for video. Sorry, I'm just going to change an internal setting to make sure you can do that. Okay, you should be able to do that now.
Okay. Mm, Okay, can you see a black image?
Yes, yeah, we can.
Hi, I'm Chris Lewis, a former engineer and
Can you hear
current
it now?
GP working at the UK's best GP practice. It was a great privilege to join the HSMA course. I was afforded the opportunity with my practice to explore the data from the telephone system. The call system monitors incoming calls, call queues, and call handlers, and records a large quantity of finely detailed data over wide time periods. Let's open a Jupyter notebook. Here you can see the opening analysis. We're reading in the file and just presenting the couple of top rows to show we've done it. We can explore the data structures and begin trying to represent them. Here you can see the weekly pattern. The big rise shouldn't be there, it's just the weekend data, and it tapers off across the week. Let's see if we can analyse this data. We're trying to get a curve for each day, averaging the days out. We can see some super curves. Monday is higher than the other days, and the peak call volume is in the morning. Here's the first 2 hours of the day. Let's try and turn this into a Streamlit app. On the left you can see the Streamlit code, on the right top you can see the git commits I went back to produce this video, and on the right bottom you can see the starting the server for the Streamlit app. Next you can see the Streamlit app, nice simple one, little bit of data entry. What does it do? I'll never tell you my age. Hooray, that's exciting. Now let's try and include what's called an Erlang calculator. The Erlang formulae were developed to manage call center times and waiting times many decades ago. Here, into the Streamlit app, we're trying to implement one. It's not part of the course, but it was an interesting aside arising from discussion. Here's a Wikipedia page showing you a little bit about Erlang distributions. And here is the Streamlit app, where we've got Erlang C formula. We can vary the parameters according to what our goals are, and we can run a formula and see whether we're hitting a service goal. Here I wanted to show you some branches in Git, where I went back and made some side chains, side branches, to develop some of the past work to show you on this video. Right, let's get a bit more serious. Let's create a license for this work. and create a README. The license on the left, the README is on the right. Here it is in GitHub. This is what all the professionals do for sharing their work. Here's a model implementing Erlang A, which is one of the other Erlang formula. Not all phone systems will give you the data laid out how the Streamlit app likes it. So the Streamlit app will give you a sample Excel sheet that tells you how to lay your data out if you need to. Now we're able to load some data, nominally represent it. We have 3 Erlang models, and based on that we have a provisional staffing level calculator. We've been playing with 4 weeks so far. Now let's get the whole lot. Here you can see a list of data. Commas at the end indicate empty columns, and commas at the bottom here indicate empty rows. I want to show you a small detour I took while analysing the data. I explored Gaussian regression using machine learning method from scikit-learn called Gaussian Process Regressor. Instead of fitting a single curve, it models a distribution over all plausible functions, weighted by how likely they are to fit the data. These plots show a smooth shifting daily pattern with confidence intervals reflecting uncertainty. The error bars are based on a Poisson distribution within each half-hour slot, a reasonable choice since there are many samples per slot and the rate is fairly stable. Smaller time windows might improve accuracy, but this works well for most of the day. Here's a long list of dependencies for the project so far, but if you look under S, there's no SymPy, which means we're not doing discrete event simulation. So let's do some of that. After building some trial samples and looking at the sample code, I've built a discrete event simulation model for a GP call center. Running the code here, you can see some summary output allowing us to try it many times over. But then I had a conversation with our ever helpful mentors and a left turn at the traffic lights, directing me to a Facebook Meta data science prediction model called Profit, which has good characteristics for modelling seasonal variation, which I had. Let's try and use the Profit model and see if we can make it work. Here we're creating some fake data just as a test. That's what the fake data looks like. There's a weekly pattern to it and an annual pattern to it. Let's zoom in. Here you can see variations across the hours and days. Now let's see if we can fit the model and learn it, and then let's make a forecast, and then we want to make a plot showing the two together. Here it is. The blue is the original data, the red is the forecast, almost like we made data for this model, which we did. Really nice model. It'll give you the seasonal variation over the days and the weeks. So where are we now with our app? Well, we have a web app where we can upload some data, we can represent the data, and we can clear blank columns in the data. We can summarize it to get mean and standard deviations for call times, call durations and waiting times. We can graph the data as a whole and spot patterns such as when there are dips in June of last year, and then we can zoom in on quiet weeks like August holiday and see which days are missing like Christmas Day. We can draw curves for each day showing the call volume across the day tapering off. This is the independent variable, and then also the dependent variables, the call duration being quick in the morning and tapering off to a stable state later on in the day, and the same for wait times later on in the day. Let's go over to call forecasting with the Profit model. We can do call volumes or wait times or call duration. We can train the model, and then we can generate a forecast. And then we get a graph showing the original data and the forecast in blue on the right. We can see the drop-off in June of 2004. There's some prediction below zero. It shouldn't quite be there, so tiny bit of work there maybe. But you can see the weekly seasonal patterns and the daily seasonal patterns in the data. And we have our discrete event simulation, pretty rudimentary at the moment, but I'm keen to see where we can go with that. And we've got our Erlang calculators. What have I covered on the project? I've learned Python, data science tools, applied it to healthcare, learned some web development, learned about project management. Where will the project go next? Lots of places, more discrete event simulation. We can re-examine some of the data. We can apply some of this to the Erlang model. This could go on and on. What have I learned from HSMA? Loads. All of the above: geographic models, regression tree classification, agent-based simulation, artificial intelligence, and much more. Would I recommend a HSMA? I absolutely would, to anyone at any stage of their career, anyone who likes a challenge in a supportive environment, anyone who wants to build the future NHS, stay on top of technology, and anyone who wants to work collaboratively. I'm Chris Lewis. Thank you for listening.
That's brilliant. Oh, sorry. Can't turn my video off. Oh, there we go. Fantastic. Thank you very much, Chris. Really nice exploration of your kind of journey through your project, and really interesting aspects that you've looked into this. I'm really looking forward to seeing how that evolves. So fantastic. Thank you very much.
Thank you.